Hello Hopewell, this is Mr. Steinberg, and today we get to start our first lesson about conic sections. What is a conic section? Imagine that we have some sort of three-dimensional ice cream cone shape. The way we can intersect this ice cream cone shape with a plane will create something called a conic section, and there will be four of them we learn. Let's imagine I had some sort of knife that can cut straight through. Let me cut straight through this cone. The intersection where my knife will hit this cone will form a shape, something that looks like a parabola. Now there are other ways to slice into this cone. I can go diagonally, I can go sideways, I can go straight down, and that will cause a different conic section to occur. But today we're going to discover what does a parabola conic section look like. We're also going to redefine what a parabola is based on these definitions and these new words. I'm going to talk about the words focus and directrix, but we already know axis of symmetry, how a parabola opens, and vertex, things like that. So we're going to bring all this stuff together, new and old. So it says, for a given point called the focus, and a given line that does not contain the focus, we call that line the directrix. The set of points, or the locus of points, that have the same distance from the original point and this line, that makes up a parabola. So if we measure from the point on the parabola to the focus, and I believe you have a yellow dotted line on your page, if we measure this yellow dotted line from the point on the parabola to the focus, it will have the same length as the point to the directrix. So the point on the parabola to the directrix. These lengths will be identically the same. If you don't believe me, I'm going to just draw one other point somewhere on this parabola on the other side, so maybe we'll look like that makes sense. Let's put it way up here. If I measure the distance from the point on the parabola to the directrix, and remember, distances to lines are always perpendicular to that line. That is the shortest distance. And if I connect the point on the parabola to the focus, it should look like these have the same length from the focus to the parabola and the parabola down to the directrix. So we can imagine this is the definition of a parabola that we're going to learn about or talk about here in Chapter 8. There's one thing that I haven't covered yet that's sort of somewhere in here, and it says the value of p. The value of p is the directional distance. It's the directional distance from the vertex to the focus. So why didn't I just call this a distance? What does directional distance mean? It means that the value of p will be one of the two things that indicates how this parabola opens. Since distances can never be negative, the absolute value of p is always positive, but the value of p itself isn't the distance, it's a directional distance. So the value of p can be negative, although when you go and try your homework in Delta Math, the Delta Math homework will always want you to give the absolute value of p when you are responding. So you might get your first question wrong if you're asked for p. Their p value is a distance. When I refer to p value, it is our directional distance, and we allow it in this class to be negative. So the value of p is from here, from the vertex to the focus. That is our value of p. If the vertex is 0, 0, or the origin, and the value of p is p units, then the focus is p units away vertically, then this would be the focus at the point 0, p. Now the directrix is located in the opposite direction of the focus. So if the focus is above the vertex, the directrix would be below it. It's still a side length of, or it's still a segment of length p, because remember, if it's a point on the parabola, it has to have the same distance from the vertex to the focus, which is the same as the point on the parabola, that vertex to this directrix. It still has a value of p units, but because it's upside, or because it's underneath, we're going to say that we're going to go in the opposite direction. So whatever that distance is up, we're going to go below or decrease it. At the very bottom of the page, we're going to learn two new equations for parabolas, and what they say might redefine what we know about parabolas. It says this: these two equations have vertices at 0, 0. So where the vertex is at the origin, the parabola has these properties. These are two formulas I want you to memorize. 4py equals x squared, and then 4px equals y squared. What you might have already noticed is this is not solved for y, it's not solved for x, but it's got the x squared variable by itself. So in Chapter 8, what's different about when we study our parabolas is we want to get the x squared by itself and not the y, or not the x. You'll also notice that the x and the y have switched from the first equation to the second. Because they switch, that means these are inverses of each other, and a parabola that normally opens up and down will have an inverse that opens left or right. One thing that I want to make again a little bit clearer is the focus. Your focus is always on the inside of the parabola. So we're going to need to know that if the focus is above or below, that means your parabola is opening up or opening down. If your focus is to the left or to the right, that means your parabola is opening left or opening right. If your parabola opens up, your directrix will be a horizontal line and have a y equals equation. If your parabola opens to the right or to the left, your directrix will be a vertical line and have an x equals equation. Your axis of symmetry is going to be determined by your location of your focus and vertex. So they're going to have the same x coordinates in common or the same y coordinates if it opens sideways. So that's what's going to determine your axis of symmetry. One last thing to end this video. What if we don't have the vertex at 0, 0, instead we have a vertex of h and k? What does that do to the formula for your parabolas? So let's take a look. What I'm going to do is I'm going to translate this left and right and up and down. So I'm going to have 4p quantity y minus k equals quantity x minus h squared. This is a different equation for a parabola. I mean, this one still is going to open up or down because it's the x value that's being squared. That's the traditional one, when x is being squared and y is to the first power. Although this one has a vertex at h and k. And another formula, 4px minus h equals the quantity y minus k squared. When the y value is squared, then the parabola no longer opens up or opens down. It will open right or open left. What determines which way it opens? Two things. Which value is being squared, the x or the y? If it's x, then it's up or down. If it's y, then it's left or right. The second thing that determines it is the value of p. If p is positive, then it's normal. Normal would be opening up and right, up or right. And backwards would be left, or opening down, upside down would be a value of p that is negative. So it depends on two things, what's being squared and your value of p. So for the first page, this is what I want you to know and remember. We've redefined what a parabola is. A parabola is a set of points that are the same distance away from a focus and a directrix. The focus is the word that we give to the point that's inside of the parabola that's not contained on the directrix, and the directrix is a line that does not contain your focus. Your vertex is halfway between your focus and your directrix. And the next thing is, and the last thing on this front page is, sometimes we're going to look at parabolas that open left and opens right. What determines which way it opens, there's two things. What's being squared, x or y, traditional or the new way, and then if your value of p is positive or negative. So I'll do this to wrap this up. If your p value is positive, that means it's going to open up. If your p value is negative, that means it's going to open down. That's if it opens up or down. What about if the y is being squared? If your p value is positive, that means it opens right. If your p value is negative, that means it opens left. Let's move on to our next video.